So you should have just completed some practice on testing and claiming about a proportion. Now we're going to be testing and claiming about a mean. So proportions are categorical, means are going to be numerical. A lot of this is very similar to the confidence interval. A lot of it is exactly the same as testing and claiming about a proportion. So things like alpha level, all this is the same. It's still the complement of our confidence level. You might also see it as a level of significance. So read the problem, identify your alpha level. The p-value is still the probability of the sample happening again. This time, you're going to go stat, test, and we're going to be going to the t-test. The t-test has two options, just like the t-interval did, for if you're given summary statistics or if you're given a list of data. The conclusion is the same. P-value is less than or equal to alpha, we reject the null. P-value greater than alpha, we fail to reject the null. And just remember which statement we're considering true in each situation. If we reject the null, the alternative is true. Fail to reject the null is true. Rolling Stone magazine claims that the lead singers in metal bands burn at least 1,000 calories during his show. For a sample of 13 shows, the lead singer burned an average of 892 calories with a standard deviation of 145 calories. Is Rolling Stone's claim true at 95%? So we have our null. This time, make sure you're using the mu symbol. Mu is equal to 1,000. Mu is greater than. Remember, at least means 1,000 or up. So we have mu greater than 1,000 for our alternative. And again, think about what the two statements mean. If our null is true, that means that Rolling Stone's claim is not true. It's not burning at least 1,000. It may burn 1,000, but it also could be under. If the alternative is true, that means Rolling Stone's claim is true. The lead singer does burn more than 1,000 calories for every show that he sings. We're being 95% sure, so we have alpha 0.05. And now I'm going to go to the calculator to show how to get the p-value. Okay. So I'm going to go stat, go over to tests, and number 2 there is the t-test. Now I want to make sure stats is highlighted. It did not give us a list of data. It told us our summary statistics. So here we have mu 0, which is the value in our null and alternate. So in this case, we're claiming 1,000 calories. Our average was 892. Our standard deviation was 145. And our sample size, it said 13 shows. So we have n equals 13. For the symbol, our alternative was at least 1,000 calories. So we had greater than for our alternative. So make sure that's highlighted. And go down to calculate. So again, pretty much the same information. It gave us our test statistic, which we're not too worried about. We care about the p-value. So in this case, 0.990. Okay, so again, round to 3 decimal places. So I'm just telling you it is 0.99 for our p-value in this case. Going back to the slide here, we had our null and alternate, had our alpha level. Now our p-value is 0.99. Your conclusion should be pretty much the same thing. As the proportion. Your first statement needs to talk about which is higher, the p-value or the alpha level, and if you reject or fail to reject. Since the p-value is greater than our alpha level, we fail to reject the null. So failing to reject means that we are going to side with the null. We believe the null is true. So again, since average is equal to 1,000, that means it's not greater than 1,000. Rolling Stone's claim is not true. The claim about how many calories the lead singer burns is not correct. It is not more than 1,000 calories. Okay, a very simple 2-sentence. Don't do any more than 2 sentences to explain your conclusion in these situations. Okay, we don't need to do more work than we have to, and just the more that you say, there's a chance that we just slip up and say an incorrect statement. Okay, now that was with summary statistics. It told us the average, the standard deviation. The next example is going to give us a list of data. E-Town claims that they forget less than 12 kids on field trips each year, on average. Below is the list of kids forgotten each of the last 10 years. Test the E-Town claim with 99% confidence. So there's our list of data. So instead of giving us the average and standard deviation, it gave us our data set. Okay, so first I'm going to write my null and alternate. Claim was E-Town claims they forget less than 12 students. So we have mu is equal to 12. Mu is less than 12. Again, we have our mu symbol in there. We wanted to be confidence of 99%. So our alpha is 0.01. And now I'm going to go back to the calculator to get our p-value. This time, I'm going to go to stat list first and make sure you're entering your list into one of your data set into one of your lists. So I have mine into L1. Make sure you can tell which list it's in. So I have mine in L1. Second quit, stat, test. I'm going to number 2, the t-test again. This time I'm going to highlight data. Now it's going to ask for some different information. The first is still the same. That's still asking what values in our null and alternate. Now the statement was less than 12 students, so I'm going to put 12 in for our null. This has L3, so I'm going to go down and make sure that's changed to L1. We had less than, so I'm going to change that to less than. And then I'm going to hit calculate. Okay, so our p-value here, again, the test statistic we're not worried about, but the p-value is 0.379. So I'm going to go back to the table to our problem now. 0.379 is our p-value. We had our null and alternate. We had our alpha. P-value is 0.379. So this time, again, our p-value is greater than our alpha level. Since p-value is greater than our alpha, we fail to reject the null. So again, we are siding with the null on this case. So the null is correct. And what that means is our number of kids that we're leaving behind is greater than 12. Okay, it's at least 12, but it might be higher. E-Town is wrong about the number of kids they leave behind on field trips. It is not less than 12 kids a year. So again, this is what your answer should look like. Okay, we should have 1 point for our null and alternate, 1 point for alpha, 1 point for p-value, and 1 point for the conclusion. Okay, so do some practice and let's see what happens.